Hey guys, we are recording this session. You should see a little red dot showing that it is actually recording. And with that, I am beginning to discuss our plan for discussion today. We'll focus on recap of security group concepts, understanding this idea of IP address scheming, address range of addresses. If you know the entire internet, like all over the world, wherever they are, wherever the people are, they live, they do whatever they are. They have computers connected together. That's what internet is. Bunch of machines connected together. Actually, exactly 4 billion addresses all over the world. That's what you can denote by a pattern that fits into these 4 boxes. And these boxes have a limit. They need to belong in this range. And if that's the scenario, like that, then there are 256 such places. We can put numbers here, 256 here, 256 here, and 256 here. And if you multiply them all, that becomes 4 billion. So there are total of roughly about 4 billion, slightly give or take. You can do the math. This is the math. And that's the number of addresses available on the internet. I should say internet version 4. There is a newer internet coming up. Actually, it has already come up. You probably have it already. I saw in one of your home IP, what is my IP questions, you were actually using the IPv6, which is a little bit bigger and a broader range of addresses, which is not currently, we're not focusing our discussion on that, but it is there available. And cloud companies use it, you use it in your homes, your company uses, and that is also easy to discuss. It is just a different numbering scheme. I think the concept that I want to discuss is very easily captured in what we have with IPv4. So let us, just for now, limit our discussion to that addressing scheme and understand that machines that are on the internet, anywhere on the internet, that means we can have this numbering scheme of 0.0.0.0/0. And that basically means all of the internet, 4 billion of them, IPv4, any address. This any address on the internet is denoted by this pattern. This is the mask. The mask is none or 0. That means you're not masking any of these boxes. And so the whole range is available in this notation. So this is just a notation. This is called CIDR notation, called classless internet domain routing. So I'm forgetting what the name is. Let's go check CIDR. What it stands for? Yeah, classless internet. No, it's not internet. Classless inter-domain routing. So yeah, go check with Wikipedia what that means and read that. And there is a notation methods, and you can see that. Here is an example of a 24 mask notation, which basically represents that you have this 192.168.100.whatever/24. This means there is a 24-bit mask. So these segments are frozen. Don't change it. You want to change it here. And that gives us a range of this, which means there are rather precisely 256 addresses denoted by this scheme of naming or addressing. So that's the mask way of communicating how many addresses are we talking about. Here we are talking about 4 billion. Here we are talking about 256. And here, how many are we talking about? Anybody? That many. That is 64,000. Or rather, 65536. That many addresses are being represented by this system of notation. Why am I so ugly in writing? Clean up. Yeah, in this system of writing. And by this 100 is actually kind of, misnomer. We should write it, it's actually immaterial what we write here because it is going to be flexible. The mask will cover only these guys. So this will be frozen. This will be frozen. And then these will change. And that's the change. And that's the total multiplication. So that's how you structure. There is one more pattern, which is, you have 10.0.0.0. 8. This pattern denotes that we were masking only the first 8. And every of these are open to any number that belongs in this range, which means there are these many addresses possible, which you can do the math. That's the idea behind a CIDR notation, which is described in this Wikipedia page. You can read that. So that with that, I think you understand, or rather, there is a fifth one. Forget that. That is, you have a specific address like 2.3.4.1/32, and this means you're masking each and every of these bytes, which means nothing can change, which means there is only exactly one address specified in this notation. There are these many, and these many notations specified by /0, /24, /16, /8, and /32. So that's the CIDR notation from a IPv4 perspective. That's how you can just address or call out names or ranges of addresses on the internet. So here is your internet, and it has all the possible 4 billion addresses, out of which we are carving out some portion, and they're saying that, these things are not your public internet. So this is our private area. So any address in that range is private. So that means we have to have this private network address range. They are these ranges. So we know that already here. One range, second range, and third range. You can denote these things in succinct fashion by writing it like this: 10,000/8. That is a big, gigantic range of 16 million addresses, roughly, that number of addresses. It is private. Similarly, this range of 172.16.0.0/12, this 12 is going to be like partially counting these 8s plus 1, 2, 3, 4. There are a total of 8 bits here. Only half of it is masked out. So this 12 indicates not all, but only a half of these bits, 8 bits, are masked. The rest are open. That's why you get a range of 1 million addresses in this 1 million, roughly about 1 million, that number. And then we have one more address range, 192.168. By the way, you should check in your home router, and your home machine should give you an address space of that number. 192.168.00/16 will give you about 64K addresses. And there is, 8-bit block, which is 192.168.0/24. So /24, 192.168.0.0. That is a small size range of addresses, and these are private. Everything else, public. And that is how the addressing is defined. That is your address. So if you now go to, say, the CloudGenius website, let's say here, and at the very bottom, you will find there is an address. So the address is scroll all the way bottom. Where is the address? Right here. See that? 24281. That is the address. You see, there is a number, 24281. And who came up with these numbers? The post office. Our US post office in our country comes up with these numbers, and they give you street numbers, and then they will know that this is the address that belongs to what? Me. I mean, that's how the numbering is, that is my name here. That name is Nilesh. So there is a name, this guy, and a number, this. And of course, there are some other things, like you can see here, the address is so much, so detailed. But there is a famous address that you probably already know, very, very famous address. It is called 1600 Pennsylvania Avenue. Do you know what this address is? What is the name for it? Anybody?
White House.
Yes, it is the White House. So that's the name. Now, who sets these numbers? The post office, of course. So similarly, there is a name and numbering scheme on the internet also. Do you know what that thing is called? The name numbering scheme. There is a number here and there is a name here. That numbering scheme will look something like, let me show you. So here is my command line and I will type, or rather I should say type a command. Dig. Boom. What do you see? So I ask a question, hey, dig out the address for this name. And that's the question. So in the answer section, I get the answer. The name b.a.cloudgenie.us has an address of, this is my address. So what does that mean? So we have a name and a number, 35 dot, whatever that number was, 185.198.209. And that is b.a.cloudgenie.us. Let's do one more quick one. We'll say, give me a, let's just adjust this. Okay, there we go. I am using a monitor to write, and so that monitor needs to be adjusted a little bit occasionally when I want to type as well as write. So now I'm typing, and I'm typing big Boeing.com. And I say, give me the address for the name Boeing.com. And what do I see? I ask this question section, question, find out the address for the name Boeing.com. And in the answer section, I see Boeing.com has an address. Address is, not is, but addresses are, and there are so many of addresses, all these. Boeing is a big company. Boeing has multiple addresses. Let's see a couple more. Do you know what this thing is called? So this is Apple company. The question was, what is the address for Apple? And the answer section gets me 3 answers. 1, 2, and 3 addresses. What is this thing called? Do you know? The system that we have, like I said, post office here decides, this name, this person, post, and this Washington White House and address and all that. So there is a system like this that maps a name to a number. Number basically means IP address, I should say, specifically IP address, not a number, but an address. Just like you saw the Apple example, the Boeing example, and a very, very simple Cloud Genius example, which is like a very small organization, which, I'm comparing with, it's not comparable. It's like a tiny, tiny business compared to gigantic Apple and Boeing. It's, that system is, by the way, called DNS. This DNS thing right there, this is the system. It is the domain name system. And I have a question for you. The question is, do you happen to have a domain name for yourself? Tell me yes or no. And if it is no, that's no problem, because we are going to buy one for $1. Let's go see. Buy a domain for $1. Like that. So I would like you to spend $1 and go to this GoDaddy thingy and buy a domain yourself. And when you do, they will want to sell you a lot more stuff than just a domain. Now remember, we don't need anything else. All we want is a name to play with. And we are going to spend 99 cents. I hope that's not a big deal. So buy it. Not right now. Don't take me wrong. Not right now, but tomorrow. Just go to a Google search engine and say cheap domain, buy a domain, something like that. You will land on this advertisement. In this ad, you can buy a name that you like, something like Corycast.com or Emily.com. Emily is probably taken. But you can find out what is taken, what is not. You can just go here and say Emily.com. It's probably gone. And so, yeah, there we go. It's taken. So you cannot take that name because it is taken. Some other Emily, or maybe somebody else took the name. And so it has to be unique. And only then this name will be available. And so what we are looking at is a company that sells name to you, to me, to anybody. So if you go here and try buying cloudgenie.us, it is taken. And it is taken by me. And so how do you know who took it? We can go to a name, what is called who is service. There is a who is service. And this who is basically look up who is the owner. And for that, a good website is this, who.is. And just go there and type the domain name. And it will tell you who is that domain. So here, this domain is owned by me, my name, my address, and all that. And so that is what you can also see, that the domain called Boeing.com is taken by the Boeing company. Now they have names of users, the Boeing company, address, California, like that. So you can basically look up and find out who is the owner for that domain. And that's the who is method of finding out the ownership. However, we are talking about a couple of different things at the same time. One of them that I mentioned was asking you to buy a name. And remember that I asked you to buy a name only for this amount. Do not spend anything more than that at all, at no other expense. And this is the money that you will have to spend because you will get to play with a domain for yourself. And we will do exercises hands-on with the domain that you have. And so you will see where we are getting with it. But remember, these guys, once they find that you're interested in a domain, they will want to sell you a boatload of stuff. Just say, no, I don't want anything. Only thing I need is a name. So you end up getting something like, Emily.com or Emily whatever else.com, or maybe something, your choice. So some random string, alphanumeric string, A, B, C, whatever, .com. And it doesn't even have to be .com. It can be anything else, like whatever is available. That's what we need to buy and have in our hand. And we get a control of that domain because we will own it. Once we own it, we can do lots of interesting things with our domain. And I'll walk you through those things so that you will understand. Now, this name system is organized by, it's called the DNS system. Now the GoDaddy company, for example, and there are many such companies, like GoDaddy is one of them. But if you say, go here to Google search and buy domain, you will get a ton of examples of companies trying to sell you. So there is domains.google, 1&1, and Squarespace, and GoDaddy, and Namecheap, and Register. And by the way, there are probably about 30 to 40,000 of such companies that sell names. Now, the interesting question that comes along is, if I buy a name, let's say CloudGenius, cloudgenie.us, that name. If I buy this name from one company, and the very next second, I attempt to buy the same name from another company, or somebody else attempts to buy the same name 1 second after I purchase it, then can they also get it? Or who controls the master at the back end or something? Is there a master player? Is there a master authority? Is there a master register that regulates who owns what? And the answer to that is yes, there is. There is an agency, it is like the United Nations, if you will, that controls worldwide distribution of these names. That name, that entity is called this. I cannot, that's the name. I can, actually, not I cannot, but I can. That's the name of the agency that regulates behavior of these seller of names, these agencies like GoDaddy. And so this is like United Nations. Not actually, but it's a, let's go read about what they have. So let's go read. What is this ICANN thing? And so in English, let's go find out what is ICANN. And now they don't describe. So maybe fact sheet will give us what is ICANN in one sentence. No, they don't. But it's a regulatory body that is in a, it's a non-profit association of companies worldwide that constitute together. So let's go to Wikipedia. That will define what is ICANN easier. There we go. So here is Wikipedia, and that is ICANN. And ICANN is a non-profit organization responsible for coordinating the maintenance and procedures of several databases related to the namespace of alphanumeric spaces of the internet. Basically, they decide the names. That's what it boils down to. But let's go see what is under the hood. Like when they decide a name, at the very top level, they need to have something called top level domain. And at the very top level, ICANN has decided, or rather historically decided, that .gov, .com, .navy, .mil. I should, no, Navy is confusing. So let's erase that. I should say .mil, .net, Do you know any of these other top level domain names that I may be forgetting?
.org.
.org. More of these. Can you tell me more? Like new ones have come up these days, exotic ones. Like coffee.
I've never seen that one.
Sorry, crazy ones have come up. Like you can basically, these are, so basically these strings are called top level domain. And so the ICANN agency, they decide what is the purpose of each of these. Like .in for India and let's go see exotic domain, TLD.
For Canada.
Yeah, .ca for Canada, right? So CA for Canada. So what they have done is decided at the very top level what are country level subdomain, top domains, TLDs, so country level TLDs are here. So they will specify which countries get what. So list of CCTLDs, and that will be, here is a list of Accession Islands, Andorra, UAE, Afghanistan, Antigua, goes on. So A through all the way to Z, to Zimbabwe and all that. So this is a long list of, and there are some exotic ones like Mongolia, Morocco, and it's in their script. Like here, this is South Korea. This is in their script, and this is Unicode. And so the Unicode specification is like this. And we can see what this means. And if you're typing South Korean, or rather Korean, you can convert this in Unicode and actually it look like that. And this is your TLD in Korean. And same is true with other countries. So that is just non-English. They're also available. They're global. And so if you go back to Z, you will probably see Zimbabwe. Where is that Z? Yeah, there is Zimbabwe. So that is the ZW domain TLD. But these are just the country ones. There are other custom ones. For example, .gov. Now, since this internet thing started in the US, so that US has taken a lot of interesting ones, like GOV stands for the US government, not any other country's government, only US government. And those are just taken. Now, any other country cannot have .gov because US took it. And so too bad, too bad, US took it. And so this .com was available to anybody who is a organization or a company. And same with .net and .org. And they're just open to anybody who are interested. Typically, conventionally, this was given to organizations, and that is like very, very, very slack, or rather lax definition of an organization. You can, as an individual, also get an .org and a .net and a .com and whatever. So I used to have my last name londhe.com. I still have it. I used to have a .net. I used to have a .org, but then I kind of lost interest in these two, so I gave up, and so I did not renew my ownership. But I keep the ownership of this domain for I don't know how many years, that 20 years or maybe something like that. So if you go back here and say dig and my last name.com, you will find something. Let's go see what I find. So there is an address right there. And by the way, that address is kind of sort of similar to what you saw here, isn't it? Because it is the same address. It also goes to the same location right there, you see? Same 35189. But what exactly is that number? I mean, I'm talking about Cloud Genius .us, by the way, .us. So US is a country-specific TLD .us. And I have craftily created this domain because of the word that I had in mind is Cloud Genius. So I just deliberately chose a dot right there and said, you know what, I need a domain called cloudgenie.us. And so they gave it to me for 99 cents, like in my first year. And so the subsequent year pricing is, I think, $6 or $7 or something like that. I paid something like $7 every month for ownership of that domain. And then what I have done, further extended it to be .a, .be. And so whatever this direction I write is in my control. In this direction, not so much in my control. I can only pick and choose what is available and then permissible. And then if I try to say, you know, I am the .gov, I try to get that. It may not be taken, but it is not available because I am not the government, right? I'm not a US government entity. So I cannot get this because I am not eligible, because I don't belong to this organization that controls the top level domain. So I cannot go and buy this, primarily because .gov is specifically dedicated to US government entities. So even if I have this idea, and even if this idea is available, and I mean not available as in not used or not taken, I cannot go and get it because it is restricted to US government. Or I can, you know, come up with some random alphanumeric string abcd.mil. So this is taken by the US military. So even if this abcd.mil may be not used, I cannot just take it because it is restricted to the US military organization. So other countries' organization, what do? They will probably go something like military.india because they control India. So anything in that direction, they can do whatever they want. Like I control these things, and I can, you know, come up with anything XYZ dot PQR dot whatever I want. I control anything in that direction, but not this direction. I don't control. I have to buy this from some agency, and so I bought that, and then I dictate whatever I have here. Similarly, in India, the military will use something like this, or maybe not, but it's their choice, their selection of what they want. Same Canadian companies may use .ca, may not use. They can use the .com, they can use .net, they can use .org, they can use Coffee, they can use I don't know what. These days, anything is available, including domains like TLD, like X, Y, and Z is also available, for God's sake. And so a very, very famous company that you and I use almost every single day has taken the domain abc.xyz. Do you know which company is this? You use it every day, like maybe 10 times a day.
Is it Google?
Yes, it is Google.
Oh.
So, yeah. So abc.xyz. And so go there and see what happens. It says G is for Google. The parent company of Google is called Alphabet. And so ABCXYZ actually is a good way to say the alphabet. And therefore, they have very craftily chosen that domain, ABCXYZ. It goes to Google, and G is for Google, which is nice. It's kind of smart. And so G is for Google, and abc.xyz is for the Alphabet company, which is the parent company of Google. And there are many such subdivisions of the company, which is behind Google, which is abc.xyz, which is the Alphabet company, and that's the name that these guys took. And by the way, there is a .google also. I think there is a .google probably, but I don't exactly remember what the restrictions, if any, are, but maybe there are. So let's go say domains.google, not google.com, but just .google. And so it goes to Google domain. So here you can also buy a domain. You'll pay slightly more, but you can buy right here. And this is the Google company selling you domains. And they are selling you for $12 a year, which is 12 times more expensive than the 99 cents that I'm asking you to spend this. And so don't spend more than 99 cents plus tax. But yeah, $1 some change. That's it. Nothing else, no other expenditure. So I don't want you to waste money. And by the way, this money will probably get wasted because you will probably stop using it. But let me tell you, most of the people that actually participate in our bootcamp end up using that domain for their own personal reasons, which is a great idea. You should think about it and maybe keep the domain and use it for yourself. For you can construct an email address for yourself that would look something like, assuming that cast.com is available, which is not, by the way. And so you can get something like Corey@cast.com. That will be beautiful. Or if not, maybe go Coreycast.com. That is probably going to be very, very likely to be available. Let's go check it out. By the way, don't buy it on Google. It's going to cost you $12. And so Coreycast.com is available. And so before you buy, I will buy it. Just joking. So let's go to that GoDaddy thingy. GoDaddy. Cheap domains. And so here, go to GoDaddy, 99 cents. And okay, it is limited to one per customer apparently. So did I buy it already? No, I didn't buy it. Okay, so I'm going to click on Coreycast.com, and yes, your domain is available. And so it is showing you like $12 price. That's cheating. So what I'll do is I'll cheat the cheaters. How do you cheat the cheaters? This is how you do it. And so they show you $12. I said, no, that's not what I'm going to spend. What do? You open an incognito tab, meaning you go to Firefox and say incognito private window, like that, new private window. And now in this private browsing, you say google.com and cheap domains. And then you go to GoDaddy again. And this time, this is not GoDaddy. Go to GoDaddy again. Oh, they're now tracking with IP address. We have to go cheat out some other method. But remember, be careful. And so if you're going to that advertisement, which gives you a 99-cent domain, like this one, they'll probably let you do it only one first time when you go there. And so you make your mind already and go there and just buy it for 99 cents. Otherwise, they'll give you like run around like they're going to give me right now. And so this special offer is only for first click or something like that for an IP address. So just be careful. If you really want to buy this domain like that, or your own name that you choose, just do it in the one sitting. If you just walk away from that page, apparently they are not letting you buy it at that cheap price. But I'm just observing whatever I see. I'm just calling it out. If you maybe have a window from the hold on. Is that available? $12. I'm not spending $12. No. Where is the window from last time when it was there? So you probably will see that this domain is available, like your personal first name, last name.com domain. So take that. I would definitely take that and use it to maybe create your own things that of your interest. Like many people have done a variety of things that they want to do with their own blog. Like for example, this guy Pantagio, a person from the last class, he created Pantagio. What was the name? Let's go search. I keep forgetting his domain. I'll give you a link. But there are there is a coffee with Kura. No, coffee with cocktails. Cocktails with Kura. There was a Sridhar Kura last time. He came up with cocktails with Kura, and he created his own website with cocktail mixes. And so that is his. So he's playing around with it. I don't know what he plans to do, but that's just his website that he created. My first cocktail and my second cocktail mix, and like that. So yes, he bought this domain, cocktails with Kura, for $1, and he's playing around. I don't know what he plans to do, but that's not the point. The point is you can do whatever you like for just spending only $1 for the first year, and next year it will cost you $7, maybe $8, who knows. And that's the annual price you will pay to maintain a domain, and you get to keep it, and you get to control it, and you get to play with it in exercises that we'll be doing, because we will do this name of some domain that you will have. So DNS domain that you will have for $1, and we will use your domain with your cloud services of a variety of different types, and we will configure this to run with your name in place. So you will be able to like operate just like you are your own company and you are running your own business for real. And that's the kind of scenario of understanding I want to make sure that you get. And the cost of that will be $1 for the first year. And if you get tired of this thing, just get rid of it. Don't renew it, and you forget that's the idea. So don't have to renew. Just do it one time. The primary goal is to learn. And so that's the reason why I strongly recommend that you actually spend $1 and get a domain name for yourself, and then we will associate that domain with a variety of cloud services. So I have this domain, I think I told you already, this londe.com, which kind of points to some address, some number here. You saw that in a dig query. And this Cloud Genie, yes, site also points to the exact same number. So what is that number, and where does it, where is it living? Like which city is the machine? There has to be a computer here, by the way, a computer that runs some services, runs something. And that is what you see when you go to this domain or to this domain. So when you visit that domain, like be a Cloud Genius, and so it shows up like whatever you see, like this. And so that is what you see when you have, you type this in the browser. So the browser is actually going at dig query and finding out the IP address for the machine that is running something. And then it goes to that machine, queries it, gets the results back, and then shows it to you. And this is what you see on the right side. That is the representation of this domain. Now open a new tab and say londe.com, and I run. And so it says default backend 404. It doesn't actually show you anything. But if you go back here and say londe.com, it is the same IP address that you see when you go to this, the same IP address. When you type be a Cloud Genius, you see what you see here. But you type londe.com and you see what? It's the same machine, isn't it? It gives you 404. Like nothing found. I don't know you. That's the response you receive. Default backend 404. I mean, this means page not found. Basically, I'm not showing anything. When somebody is looking for loanday.com, I'm saying, yeah, nothing, not visible. But there are a ton of services that are already functional for my domain, loanday.com, already, even right now. For example, if you go back to this command line and say dig and loanday.com, tell me where your email server is running, because it is running. And so we'll go check, and it shows me that it is running. And so I got asked the question, domain loanday.com, where is your mail exchange? MX. So the answer section says your mail servers are running on these 5 locations. 1, 2, 3. And what is that? Why is it saying Google here? Do you know why is it saying Google? It is because when I go to my Loanday mail, okay, hold on. When I go to my Loanday mail and I will say add an account, and there I go type my loanday.com address, and come on. You see, I'm going to Google Gmail and I'm typing loanday.com and typing the password for loanday.com and then typing the token. There we go. And the 2-step verification finished. And I am in my Loanday email. And so this is my personal email, by the way, not the company email, but I can compose an email and send it to anybody I like. I don't use it much, but it is functional. And it is operating on Google servers. You see, right there. So what do you see is that I am using the domain loanday.com as my personal email address and a service that I have taken from the Google company. And what you're looking at is I have my domain with an A record, address record, pointing to this IP address of the computer that runs nothing. I have my mail exchanger pointing to Google, which manages my email for this domain. The domain happens to be loanday.com. And like that, on a domain, you can have a variety of services pointing to different things and other types of, we'll talk about other types of services soon that are mapped to a domain and they're running something somewhere in some cloud. That I am mapping this domain name itself. When I say http://loanday.com, it goes to the machine that runs this website, but I have configured it to show nothing. So it shows nothing right there. And then in my mail services, I have configured this one, the mail exchanger, to point to Google. And I'm asking Google, hey, Google, can you give me a, so I shouldn't say, hey, Google, is going to now. Okay, forget that.
I'm not sure how to help with that yet.
I know. Okay, I've disconnected that. So I'll say, hey, Google, can you please give me email services? And that is software as a service provided to me by Google right here. And I can send emails from here to other people and like that and send, and it will go. And Google will actually transmit that message to the destination because I'm using Google as a service, software as a service, Gmail, software as a service. And I'm using that to map it to my domain like that. Same thing I'm doing with the actual business that I run. So I'll say dig Cloud Genius and tell me the mail exchanger. And what do you see? I ask the question, tell me your mail exchange. And the answer is Google again. Because this is also on Google. as you can see, my email for Cloud Genius is also Google. And so you can see that I am receiving emails and all that, and that is the Cloud Genius domain. And here's the email address. And you may have seen email coming from me. So it comes actually from Google. I mean, the Google service that I have rented and mapped to my Cloud Genius domain. That's where I use. This is the interface to you. And that is my business email service. And I chose to not have any web visibility for this domain. So I show nothing. Nothing is also known as 404, which is showing you nothing. I have a page that shows nothing. That's what that 404 actually means, is nothing. 404 is a standard error code on the internet. So now you saw some examples of what I am trying to build towards. What I'm really trying to do is to help you understand that this TLD that I talked about, top level domain, which can be X, Y, Z, and then you buy a domain like this from them, and then everything here you create, or maybe put a www if you like, or if you don't want, don't do it, like I have not done in my company. I did not like the idea of www, so I did not choose to create this string of letters. You can put whatever you have, like, you know, monkey, or, you know, whatever, .cloudgenie.us. And this is totally in your control. So whatever you're looking at, this portion, this portion, this portion, they are called subdomains. And if you put another dot and put something else here, it is called another subdomain of subdomain of cloudgenius.us. Yeah. So that domain, you have a subdomain of this domain, which has a TLD of .us. So TLD, domain, subdomain, 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 logos like that. And you can convert, or rather create whatever you like what .ever .u .like .cloud genie .us. So TLD, domain, subdomain, 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 subdomain. And you can create these, any number of them you like. There is actually no limit. It doesn't make sense, but it could. So it's up to you. And so in my example, B is a subdomain. A is another subdomain of this domain. And so then it kind of reads like an English sentence. And that is why it makes sense to me. I don't know if it makes sense to you, but that's the reason why we have it like that. And so because it makes sense to me, so I wrote it like that and then created my entire site based on that sub of a domain .tld. That's my choice. You can have your choice. And so most conventions typically use a www. And so you can actually attempt to type www.cloudgenie.us and go there and see what happens. So just go. And it says nothing. I think this is not a good thing. It's bug. Honestly, I think it's bad, because it should actually, in my mind, go automatically to this website. It should automatically forward itself to this website, because that's the idea. Now, apparently, I did not bother to do it. So it's my mistake. I should have fixed it, and I should have taken that www.mydomain.us, and I should redirect it to the proper name that I like to use, which is this name right there. I should have done that. Apparently, I was either lazy or dumb or something like that. I forgot about it. Probably forgot is the right way to think about And let's see if there is a B dot, A dot, maybe. No, that is also missing. So you see, I seem to have forgotten about this www thing completely, and that is actually bad idea. It's not technically inaccurate. It's just bad. Bad in that people who hear the name Cloud Genius and know about www for a convention that will type something like this, and they will get a 404, which is bad for business. And therefore, I should learn from this and actually go about fixing it at some point. So maybe tomorrow or day after, whenever I find time, I'll go fix that and put a redirect rule. What is a redirect rule? A redirect rule basically means if somebody visits www.cloudgenie.us, you know what? Please go here. Go to this location. So all it needs for me to go and correct the situation is to create a redirect rule like this. So anybody who visits here, yeah, go there. That is my main site. Anybody who visits maybe www. I'm just extending the idea. I think you get the point. So you can anything that you like here, whatever .cloudgenie.us, you should just redirect it to this site. Maybe that's a good idea. Maybe it's not. But it's really up to you. I seem to have completely ignored the idea, and I just ran into it because I'm seeing it like probably first time that I thought about it, and I just told it to you. And I think that this is a mistake, my mistake. I should have done it, but I haven't. Boo. Okay, so I will do it at some time whenever I find some time to go in the back end, and I'll show you what I do in terms of making this thing happen, so that you will understand what a redirect is. Redirect. That's what I need to put in place, and I'll show you. There are various ways of doing the same thing, and I'll show you a couple of different ways. Now, having understood this piece, the next logical discussion I would like to have is this ICANN that I mentioned. Is a central worldwide, only one such agency which actually controls all of these 50 or so thousands of registrars that sell names. Like GoDaddy was one such example. There are probably 50 or 60,000 names the worldwide that sell, maybe more. And they all, when they sell a name, they register with ICANN. That's the central regulatory point. So if I buy a name from some of these agencies, then they're immediately marking it as sold, and then anybody else cannot sell it because it is taken. And so when you have a domain that is about to expire at the end of the year, that they will notify that the person did not renew. And so that becomes available for sale by other people. And so other people can, at that time, take that name if they're interested. And then any of these sellers can actually sell that name because it may be available at the end of the year. And so if you don't renew it, it's gone. It's gone to the other people because they'll take it. And that's the scenario that you want to understand, that this ICANN agency regulates names worldwide. And these names are mapped to a variety of services running in the cloud. For example, I mentioned the A record mapping to a domain, a website like this 404 you see. Or what you should see is actually this, but you're not. You have mail services mapped like this. And so what you're looking at, these and these can be located through a dig query like this. And similar to this, very, very similar to this, is another type of record. That other type of two types of record we just briefly discussed. They were the A record, also known as the address record. It basically maps a name. I should not write it here. I should write it name to address mapping. That's the mapping between a name, a domain name, and an IP address. That's called an A record. It's called record type A, the full name address record. And this is what it stores in the DNS system. You can query that like this, dig, whatever you like. The other record we discussed was MX record. It is the mail exchange record. It keeps track of the priority and server names or IP addresses. And you can have multiple priorities, like, this priority number 10 goes to that server, priority number 20 goes to that server, and like that. So if you have a priority which is a lower number, that gets a bigger priority. So an email flowing to the destination mail exchange will automatically land in this server here, which basically looks like oh, come on. Oh, am I not typing properly? Looks like this, like mail service. So this is what it looks like from a server name or IP address perspective. The mail will reach that machine. So this machine is maintained by Google, and they are managing the mail service for me. Mail software as a service, SaaS. This is the SaaS application provided by Google. I'm renting it and mounting it to my mail solution for me, for my company, and for you. By the way, each one of you also has a Cloud Genius email address if you're interested. If you are, it's your choice. You need to ask me, I give it to you for free, and you will keep it. It doesn't expire. The reason it is free like that is because these guys, Google, has given me unlimited supply of email address and storage space because we are an educational institution. And so this account that you see, that may be of interest to you. So if you go to drive.google.com, you see the storage available, and it is basically unlimited. If you go to settings and, no, not settings, where is settings? Drive, storage used. Yeah, so here the storage used by me is, I think, some terabytes of storage, the 3.6 terabytes. And if you want unlimited storage, you can also get it from Cloud Genius because Google gives it to me, so I give it to you. If you like, you take it. The reason why it is free is simply because your account at Cloud Genius can use unlimited storage. And it basically means that you are a student, which you are. And Cloud Genius is an educational institution, which we are. And so as a consequence of Google's policy to help educational institutions, they are giving unlimited storage. So as long as you comply with Google's terms and conditions, this is yours. Take it. Ask me for it, I'll give it to you. I'll create a login for you and give it to you. And you can use it. Google controls it, they manage it. If Google goes out of business, don't ask me for help because I can do nothing. And so just remember that this is a service provided to Cloud Genius as an educational institution, and I'm going to transfer it to you as an account. So you get a login like I have a login here. This is my login. You will also get a login like that. And you will be able to use whatever you want to do. Just do it legally according to Google's terms, which are right there. And yeah, do whatever you like. So that is service that I'm using. But back to our DNS discussion. So like this record type, there is one more record type, and we'll talk about that next. That record type is called canonical name. See name. Canonical. It might sound fancy to you, but it is not. It is simply, let me describe it in a different fashion. So a canonical name record or a CNAME record is basically an alias. Like, sometimes people think that the name Robert is very difficult to say. So they make a short name, Bob, because it is easy. Apparently, Robert is very difficult. So they make a short name, an alias, like that. Sometimes you may have seen some very long Indian names that you cannot probably pronounce, and even I cannot pronounce. And so, like, I have seen this. Yeah, where is that name? Yeah, there it is. So see that is actually a real name, and it is this, and it is on Wikipedia. And I can try to pronounce this name, but let me try. It's Venkata Narasimha Rajuvari Petta. Well, I did that because I am from India. So that is kind of hard, So we have to come up with a short name for this, Venkat Narasimha Rajuvari Petta, whatever that name is, to make it like short, like VKZ, for example. And so that's the short name for the station code. And so that is what is called an alias, by the way. So you can have a very long name like this one is an example. And by the way, this is actually a place where I have been to. I have been to this location, and it is a railway station where I visited. And it, come on, where is that? It should be right there. And this is it. So this is the station that I have been to. It looks like pretty much like this. And so this is the place in India. It has a really, really long name, like you saw. But digressing, stop the digression. Back to here. What we are really talking about is an alias. So Robert becomes Bob. And some other complex name, for example, if I go to a machine here and I start a running instance and I launch an instance, and the instance will give me a longish name, for example. I'll show you some examples of this. Sometimes you will see that Amazon will give you a longish name that might look like something like, come on, example, not available. Okay, no worries. We'll just create a machine and say launch an instance, and we'll see a live example. So here we have Ubuntu server, T2 micro, review and launch instance, and here we go. Launch an instance with a Nilesh key pair and say boom. Now, as a consequence of launching this machine, I am getting a very long name right there. And the long name is this. Copy that. And it is so hard to remember that I have to actually start a machine to come up with a name. And that is how the long names look like. I mean, come on, who's going to remember that, whatever that thing is? It's like Venkat Narasimha Rajuvari Petta. Are you sure you can remember this? I don't think so. So what do? We come up with a short name for this. Let's call it whatever. Now I can remember that. So this suddenly becomes a alias for the. So what I'm really saying is that this is the long name and this is the short name corresponding to that. So here is your CNAME, whatever.cloudgenie.us, and the full name actually is whatever that thing is. And so that's how you can simplify. Or even further, simplified name, something like that. You can put whatever string you like here, www, for example. But that should not be the case because it will go to my main site, not to this box. So the box we just started in Amazon, this box is running right now. And that is how you create services for yourself using raw infrastructure. So this is a raw machine right now available to us from Amazon. It has a public DNS name like that, which looks like line number 9. And it's very hard to say, hard to communicate. So you create a canonical name for it and tell people to go to abc.cloudgenie.us. and they will automatically go to that longish name. That's the idea behind a CNAME. So how do you store and tell the world about this thing? Like this CNAME thing, for example. How do you tell and advertise? The world should immediately know that I have that thing there known as abc.cloudgenius. So I have to go and tell the world, which means, first of all, I need to have something running here. Now this is a box that I just started, and it contains nothing, and it is currently initializing. So I need to copy that and actually go connect to it like this, which I will. And I connect, and I say yes, and I am connected. Okay, now what? Now I have connected, but what actually runs there if I go to the browser and say, boom, open it? So I see nothing because there is nothing. So it's a raw machine. Like this machine doesn't run anything. It has ports open. We can see inbound rules are open. Actually, they are not. So let's go modify our security groups and make sure that we are allowing inbound access to port number HTTP, port number 80 from anywhere on the internet, and also allow HTTPS from anywhere on the internet and save. So now our ports are open for HTTP and HTTPS. We just opened our ports because our security group was tight and constrained only for SSH. So I expanded it. And now I will go to that website again. Hey, EC2 blah, blah, blah number. So open. And it says unable to connect because on that box, even though our security group is open on this running instance, the security group inbound rules allow port number 80 accessible from anywhere on the internet. And so is 443 open to anywhere on the internet. But there is nothing in the box. So it doesn't show you anything. So what's the point of this machine? Nothing. So why are we talking about it? It's because I want to make it something useful. I want to actually run something there on this machine. So how do I do it? I go to that machine, and here I will run some software. For example, my plan is to run a web server. So I just run it, and it is getting installed, and it will run Nginx and show me an empty page as opposed to nothing. So this page that you see, which is unable to connect, now if I refresh like that, I say, welcome to Nginx. Oh, something is running there now. That's awesome. So this machine is not like dumb and empty, but it actually runs some software that I just installed right there. And this is where I'm running the Nginx application, Nginx web server. So it is now showing me welcome to Nginx page. And if I want people to go to this location, I can tell you, but how do I tell you? The only way I can actually say this is in a chat window. And that is kind of boring. Not everybody can do it. You cannot even talk about it on the phone. Say, hey, go to what again? EC2 what? That's the problem, right? So you simplify it by creating a CNAME. Now take this CNAME and give it to everybody and say, hey, go to this location. And boom, I just typed the second one also. And if I try to go to that location myself, it doesn't know what to do because there is no relationship between the line number 8 and line number 9. They don't know each other. There is no canonical name set out already yet. So if you go and take this query and say dig, the answer section is some IP address from some other entry, which I think is actually wrong. So let's not use ABC. Let's go see something like really random, like this, for example. And if I take that random thing and say a dig query, the dig, and then that random thing. Okay, I see that pattern actually is going straight to one of my machines in the Google Cloud, so it automatically goes there. But I don't want it to go there, so I need to modify my records. Apparently, all of these strings, whatever random I put before Cloud Genius, it just goes to this address. That's how I've structured it. But where do I go and structure these things? Like, where do I go and specify that anything I put here, like whatever I like, or A, B, C, or whatever like that, they all seem to go to this address because that is my entry in the DNS system globally. How do I make a change in that system? You need to go to a DNS server and make the edits in there. So my DNS server for the domain Cloud Genius is specified by a record type called NS, the name server record. And so if you now go and first of all, this is a digression, by the way. So if you go look at dig cloudgenie.us and find out the name server, please. And so it will tell you that the name server for Cloud Genius domain, the question is, what are the name servers for Cloud Genius? The answer is Cloud Genius has two name servers. One of them is aaron.ns.cloudflare.com, and another one is gabe.ns.cloudflare.com. Now, who is Cloudflare? Cloudflare is a software as a service provider for name servers. I am using their name servers as a service. And so I need to go to Cloudflare and edit my DNS entry for whatever I like line number 12, for example. So currently it is this number, which I need to remove and instead place line number 13 in place of ABC. So let's go to my name server, which is managed by a company called Cloudflare. So I go there and say, hey, Cloudflare, can you please let me edit my DNS? The answer is, first of all, give me a password. So I'll say, here is my password and let me in. And so it says, okay, give me a two-factor authentication. So I'll say, here it is. And I say, let me in. And then I am in. Now in my domain, I have several domains, by the way. One of the domains I want to use right now is the Cloud Genius domain. And there I want to go modify my DNS. And there I will have to look up this ABC thing. Do I have it? Or rather, I should search for ABC first. Do I have it? No records found. Is there another entry that points to everything to that same IP address that I do not want it to go? Yes, there is a wildcard entry. So I will override that wildcard entry by putting ABC and having it go to this line number 13, like that. And so I would like ABC to put a canonical name entry pointing to that location, which is the one that is hard to say. It is like Voldemort. You cannot say that name. Apparently it is, yeah, it's just a bad joke. So back here, what I want to do is actually create a record called canonical name, CNAME type, and then go to ABC and put in this name, and then put a 2-minute time to live, and then add a record. Now when I add a record, I now have a new canonical name record created in the worldwide DNS system managed for me by this company called Cloudflare. And they are a software as a service provider as far as I am concerned. And I'm using their DNS service in this example. By the way, they have several services. One of the services that I am showing to you right now is the DNS service right there. And in there, I created a ABC as a canonical name, modified a few seconds ago, and is an alias of that Voldemort, this line number 13. Voldemort, cannot say that longish name. So now I have created a CNAME record. Now let us see if the internet I mean, the worldwide internet. Do you internet know about? Do you, hey dear internet, do you know about abc.cloudgenie.us now that I have created an entry in my DNS servers from Cloudflare, which is a managed service? So the world should now know that abc.xyz, abc.cloudgenie.us is Voldemort. And there it is. So what is the question? Question is abc.cloudgenie.us, where are you? And the answer is abc.cloudgenie.us is a canonical name for blah, 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 whatever that blah is. And that's how you just saw me create a canonical name shown in line number 12 that maps to line number 13, which is the same address given to me by the Amazon company. This machine now has a friendly name called abc.cloudgenie.us. So now it has a friendly name. So now I can tell you, hey guys, can you visit abc.cloudgenie.us? And what you will find is it is not 404 anymore, because it is now pointing to this Voldemort thing, which is this machine right here, which is going to refresh and show us the Nginx page, because that's what is there. There's the Nginx page, and what you see in the web browser is abc.cloudgenie.us, which is in the chat window also for you. And I don't need to let you wonder about what that, God knows what that thing is. It's like Venkata Narasimha Petta. I don't need to worry about this EC2 dot blah blah blah, because it is so difficult. And that's the idea of CNAME. Line number 12 and 13. To get to that, I had to make sure that you understand that there is this record called NS, which is also important. So now we saw how a DNS entry is created using a DNS server that I have used the example of Cloudflare. When you buy a domain for yourself, you will have a DNS server already available to you for free from GoDaddy. Because you bought a domain from them, they just give you a DNS server. That's because that's how they will like to, maybe spam you for more things and make you buy more stuff from them, but they're giving you a freebie. So it's okay to use that freebie. It's not, doesn't hurt. But that DNS server is also available to you from GoDaddy, and you don't have to go to Cloudflare. But Cloudflare is just another name server that I like. And so I use them. And this is something that is of importance because this is free, right? This free thing doesn't mean it is great. It means it is free. That also might mean that it is not good, but maybe it is good. Free doesn't mean bad. Free just means that it is free, and free as in $0 free. Free doesn't mean open source. Now Cloudflare is, some parts of it are free, some parts are paid, but it's a pretty good service and I have liked it. Prior to that, I used to use a free service from DNS server for free from my company that I used to buy domains from, what's called namecheap.com. I still have my names in Namecheap, and they used to give me a DNS server. And about 4 years ago, boom, something happened. What happened? The name server that these guys, Namecheap guys, provide died. And I did not even know. And so I think it is an old news. So here, the Hacker News. Namecheap servers are down, and this is like 2012. And I'm struggling, and I'm trying to figure out what's going on. And my machines are all up and running, like the computers that I have. These guys are all functional. My services are running, but then customers are not able to access this site because the resolution of a name to number or a name to CNAME to real name would not translate because the DNS server is broken. And that's when I realized that I should not be using cheapo services that are bad in quality. And so I had a hard lesson that day to not use free services that are bad. So I went away from here and I did not go to GoDaddy. But it's okay for you to go to GoDaddy for learning for first time. But when you're setting up a new business, don't use GoDaddy's name server. That's the key thing to remember. If you're really setting up a new company and you're forming a new entire entity and new business and new sites and services and a bunch of other things, spend your time and effort carefully and don't get attracted towards free stuff. So, but for the exercise, totally fine. GoDaddy is totally cool. $1 you party for one full year. Party? Yes, party. I actually love these things, so I call it party. But you just have some fun in learning what these things are. So that will give you a good solid perspective on what is the domain, how do you map it, how do you manage the name server, how do you run actual services, connect it with mail services, connect it with God knows how many of these different types. We will bring them up. And I'll show you how to do it, and you do it yourself when you have fun, and when you get bored, throw it away. If you like it, keep using it. So this Cloudflare thing helped us create a variety of records in the global DNS system. And you can modify the records, and you can create A records, and you can create MX records, and you can create CNAME records, and you can create NS records, and you can create a variety of different types of records. So if you go to, again, that Cloudflare thing, you will find that there is this record now available, which I just created a few seconds, maybe a few minutes ago. And like that, there will be many, many records like this for my domain in Cloudflare. So let's go see all of them. So by the way, this machine, it has served its purpose in life. It has shown you how do you set up a site and how do you create a name that looks like kind of this Venkata Narasimha Raju or Ipetta complex sounding name, that thing, which is so hard to say. So I created a short name for us, and that name happens to be ABC. And I created that in my DNS system. This is how it looks like. Canonical name entry, alias of that longish name, and that purpose is done. So I'm deleting it and say, okay, bye-bye. The name entry is gone. This machine is also about to be killed. And I say machine instance state, terminate, and you get die. And so machine dies, this site is dead, site will not open anymore, and you go back to 404. And that is how we were to begin with. And so we have looked up our DNS record, modified it with the CNAME entry, with a real machine that we create here. It is still dying, it will die. And when it is dead, it's dead, and the bill stops. And then the core idea being DNS. So let's go recap our DNS discussion. In the DNS segment, we are searching for ABC, so we'll remove the search. And now you will see all of the records of DNS for the CloudGenius domain name. I have 6 of domains here apparently. And out of that, this domain is of the point of discussion for which we have DNS entries, and there are a lot of them. By the way, every entry that doesn't have a name with a wildcard entry and asterisk, you see that asterisk right there? This star is an asterisk, is a wildcard entry. It goes, everything goes to boom, whatever that thing is, 35.185. By the way, what is that thing? 35.185, what is that? So it is the IP address, console.cloud.google.com. It is the IP address of my cluster. My cluster of machines running Kubernetes, the front-end IP address for that is right there. And that is the IP address you will find here as the load balancer. And that is the same 35.185.198.209 IP address is the IP address that I have given it to this wildcard entry. So any and all of my services in the CloudGenius domain, and also that londay.com domain, they all go to Google Kubernetes Engine at this IP address location. So all these services that I have consolidated in my cluster, in the Kubernetes cluster, is running here, including this example, chat.cloudgenie.us. What is this? It's a separate service. The DNS name is chat. Let's go see what it does. So if you go to this site, you will find that this is basically another canonical name, or not CNAME. I think it's an A record. So it's an A record. The domain name is chat, and it goes to, let's go find out where it goes to. So we'll go to a dig query, clear up, dig, and you will find that it goes to this. Actually, it is a canonical name. Sorry, I misspoke. You can see that the answer is giving you that chat is a canonical name. So it's like that. So chat actually is a canonical name that aliases to CloudGenius. And CloudGenius itself goes as an A record to the IP address of the front end of the Google cluster that I am running. Like that. So it's a two-step process. First step, CNAME. Second step, IP address. And that's how any traffic that goes to chat.cloudgenie.us also ends up with that same IP address. You can also compare dig lothe.com, and you will see the same thing right there. And here you will find what we are dealing with is pretty similar to what you saw before. The same IP address, the same culprit. It is the cluster of machines that I have running in Google Cloud, which is where I toy around. I not just toy around, I run my business there. And so a bunch of different services that I want to create, I just go into my cluster and start them up and expose them through this IP address. The expose happens at that address, and then I can configure this software. By the way, that chat thing is actually a separate software that I run that looks like this. And here I can invite people in Slack chat if I like to. So that's just one service. The other services, I have the Cloud Seminar. Another example. Now this is actually a bucket. So if you go look at that, and you will find out what I mean by a bucket. And I think you already know what a bucket is. It's a simple storage service bucket. So if you go to the Cloud Seminar, and go do a dig for that. So you go back and dig the Cloud Seminar, and what do you find? You find that the Cloud Seminar has multiple A records. Now, where is this coming from? This is coming from the Amazon company, which has given me these addresses as the A record for that particular domain. But behind the scenes, what do you have here is, if you go to Amazon Cloud, go to S3, you will find that there is a bucket called the Cloud Seminar. And this is the bucket where I am storing the content that becomes visible here. And this whole thing is actually further protected by another type of service that I will be talking about like right now. And that service is content delivery networks. It's something that helps us take content from one bucket and make it globally available. And that is the idea behind content delivery network. And it requires some discussion. So I'll talk about that right now. And then you will understand what is going on in the discussion that boils down to this machine mapping to a CDN, content delivery network, which in turn points to a bucket. So that's how the structure is laid out. But for simplicity, you can skip this and go straight to a bucket. That also works. And I'll give you that example also. This is a slightly complex example. Another simpler example with the will be this fungibleclouds.com. And if you look at this domain, it is also a domain that I have, and it points straight to a bucket in S3. And let's go see this domain and go do a dig on that. Let's go find out, dig. So here we have dig fungibleclouds.com. And it has, I think, a CNAME. Oh, sorry, I think my mistake. The name is not this, but blog dot, that's the name. So it's a web blog that I wrote in 2012 and I never bothered to update it ever. But it's there as a good example for us to discuss. And that's primarily why I created it, is this location. If you go dig it, you will find something that is you are very, very familiar with. At least if you have done the take a picture and put that in a bucket exercise, then you know already this thing. And in that scenario, you will notice that this blog.fungible.com, fungibleclouds.com, is actually a canonical name that points to this longish name. And that longish name, let's go see what that does. Let's go copy the whole answer section and go back to our note sheet. And paste it right here. And here you will find that blog.fungibleclouds.com is actually going as a canonical name to a longish name. And that longish name itself is assigned to me by Amazon because I created it's another canonical name to a name issued by Amazon, which is that name. And that name itself is an A record to an IP address that Amazon manages. So it's a three-part process if you look at that carefully. CNAME, then another CNAME, and then an A record. That's how it is structured. So at the foundation, there is a machine that I don't manage, but Amazon does, and they have given this IP address to that machine that they have given a friendly, this is not friendly, but this is their name. Line number 24 is a long name that also shows up here and here and here. You see that the same name shows up in multiple places because it is the same name. They're just reusing that. It is actually the service endpoint for Amazon S3, the bucket service. And then I have created a bucket inside that bucket service called blog.fungibleclouds.com. So we'll go here and look at the bucket in S3, and you will find one of my buckets is this blog.fungibleclouds.com. And if you carefully look at that bucket, the last time I edited that bucket was in August 3rd, 2012 at 3 p.m., something like that. So since August 2012, I haven't bothered to update it. But that bucket is there and it is running. I mean, there's nothing to run. It's just a bucket where I store stuff. And I stored stuff that looks like fungibleclouds.com. It's a blog. It looks like this. That's the blog. And this was the last time I was writing in maybe 2012. And then the bucket looks like a website. And that's the content that I never bothered to update, but that is what is sitting in this bucket. And that bucket endpoint shows up like line number 23, because that's the name of the bucket. And then it expanded that to make it a site representation of that bucket. So what you're looking at, the highlighted portion, is a site representation of the bucket that I have created here, like this. If you click on the bucket and check its properties, you will find that it's a static website hosting permission. And the endpoint is what you see in line 23. And so what I have done further is that this is what Amazon gave me, line 22, the longish name. So I created a CNAME for that. And I did that in the DNS corresponding to this domain. So where is the DNS corresponding to this domain? Let's go find out. How do you find? You go dig and NS. And so you will do that query right here in terminal and say, where are you? So apparently that domain is also in Cloudflare. So let's go to Cloudflare and tell Cloudflare that there is this subdomain called blog, which is a part of the domain called Fungible Clouds under the .com TLD. And in there, I need to create a CNAME for the blog subdomain with this longish thing. By the way, that is already there. So let's go just check and go to Cloudflare and Cloudflare and login. And there you will have login. And then you will have various domains. And one of the domains that I want to go is this Fungible Clouds domain. And so I go to that domain and look for the DNS records and then look for blog, blog there. And come on, there. And so see, blog is an alias of the blah, blah, blah longish name. And that is already there. That's what you see when you visit this website. It automatically goes to that website, which is a bucket representation, site representation of the bucket inside. And the bucket happens to be this bucket configured as a static website. Same bucket here in Amazon, this bucket called blog. Just remember that you have to name the bucket to match whatever you want the domain name to be. That is a critical thing to remember. So you want to create a new website like Corycast.com, for example. So you need to go to Amazon and create a bucket like here with the exact name, Corycast.com. That has to be the name. If you do it that way, then you can create a new website using just a bucket. And without having to pay too much, like few cents a month, maybe less than a cent for a month for a short, small website. And that's what you will get. And you can then use a name server that you have from GoDaddy at that time. And so you can then say dig Corycast.com and its name server will be GoDaddy. So you go to GoDaddy and say, hey, GoDaddy, can you please put a canonical name for this domain and map it to my site representation of the bucket, Corycast.com. And then you fill up your bucket with the HTML, CSS that you need, and then your site is live without having to maintain a server. This idea is called serverless sites using buckets. That's the idea. You can do that very, very easily in a matter of few minutes and a matter of spending $1 for the domain and 1 cent per month for the hosting. Literally less than 1 cent probably. Probably it is free for the full year because you have a free account to begin with on the Amazon. So that's why it will be free for you. The storage will be free. And that's what I think you should do as an exercise. Just take it to a bucket and map it like this canonical name to your my site representation of the bucket that you create and fill it up with content. That content will show up in www.corycast.com, provided you buy that domain name. If your domain name is different, so you should use the different.com name in that case. So it'll be different. Otherwise, you'll probably get this domain, which is fine. Okay, let's see. Do that. By the way, do this exercise if you find it interesting. I hope you understood what I'm asking you to do. And I'll quickly recap as to what did I just ask. I said, get a domain, create a site, fill it up, create a bucket like this with your domain name in mind. So the bucket name has to match the domain name you will create. So if you want to create a www.corycast.com, you need to have a bucket name that matches www.corycast.com. If you want to just go with abc.corecast.com, then the bucket name has to be this. And then you will create a CNAME for your my site representation of the bucket, this. And then you fill up your bucket with the content you want people to see when they visit line number 32 or 31 or whatever you want to, whatever you want. Or maybe you want nothing, like just this, like just this. That is also okay. Just remember that you need to then create a bucket, my site representation of the bucket named this. So you need to understand what name you want people to go and see, and then you create a bucket corresponding to that name, and then make this DNS entry in your DNS server for your domain, create a CNAME, and you are up and running. Up and running. You just make sure that you have to create a site representation of the bucket, which means you go here to your bucket like this and go to check its properties. And there will be a section on static website hosting, and you say activate. So basically say use this bucket to, I think that's the button. So let's go let's go see a fresh new bucket and see what pops up. So you'll go create, say this, it's already, I think that one's already done. So we'll say maybe this bucket, and you go check its properties. And so it's bucket hosting. You can disable it and save. So I just disabled it. Now you can enable it again and say, okay, use this to host a bucket, use this bucket to host a static site. And then you type in the index document, which is typically index.html for the website that shows up in the bucket, and you save, and then they will give you bucket hosting, and that's the endpoint. So the endpoint actually can be very easily constructed. What you need to just do is remember that the endpoint typically looks like your bucket name dot S3 website dash US East 1. That's where typically people open buckets, is US East 1, but it can be different. For example, it could be US West 2. Like in my example, I have US West 2 here, and this is US East 1. So you can, depending on which region you are in, which region bucket you have, that might be a little different. So you have to go and check that portion, but your bucket name goes right there. So if your bucket name is www.corecast.com, that's where it will be. Or it could be ABC, or it could be nothing. And so that's how you will find out the site representation of your bucket, and then put a CNAME to that name, and you're done. Then you can just visit that website. People will see what you put in the bucket. You have to create an index.html that will show up. Any questions from this? This is like a homework, and that I would like you to do. So if you have a question, you ask.
Yeah, it makes sense. I'll definitely give it a shot.
Sweet. Please do. Please do. And you need to write simple HTML, put that in the bucket, and then you should enjoy. Now, when you do that, by the way, you are doing like the first time. So you're probably doing it very, very simply. And so let me show you how to do it properly for a large scale business.
Okay.
So I think the homework is just a simple one right now. We'll get to the large scale business scenario later on. Let's first do the simple thing. But I'll describe to you what the large scale scenario is going to be. And that idea is line number 19, CDN. And I'll talk about that, but it is not homework. Just a concept to understand what I'm talking about. So we'll go back here to our notepad and understand what this idea is, which is CDN. So where is line number 19? Clean sheet of paper, pen. There we go. So what I have been discussing is that you need to first of all have an index HTML file, and it can contain whatever you like. You put that in a bucket. The bucket name has to be matching the ultimate domain name you want people to go to. So if it is corycast.com, then the bucket name has to be corycast.com. If it is something else, the bucket name has to be that exact thing. Now, once you have an item in the bucket, you need to ask the service provider, Amazon, hey, convert this into a static site. So they will do it. You just click a button, they give you a URL. The URL will be looking complexy, like, http xyz.corycast.com blah 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 US East 1.amazon.aws.com. Oh my God, and that's so hard to remember. So what you do is you go to your DNS in GoDaddy, not GodDaddy, GoDaddy. Yeah, however you write it. So GoDaddy and DNS, and then you say create a CNAME for XYZ, canonical name, and go to this, whatever this Amazon gave you. It is the static site representation URL for the bucket. You create this record for your domain in your DNS using the CNAME, and boom, you're live. This index shows up. HTTP, whatever domain, subdomain.corycast.com. It just shows up. You spend $1 plus tax on the name itself. Storage is free, and you enjoy. This is very simple. Now, how do businesses do these things for real, for a worldwide audience, like large scale? That's what I want to talk about next. So where is my browser? Right there, here. And we'll go to that website, Fungible Clouds, and read one of the articles there. One of the articles that I wrote in 2012 actually describes this idea. So there's no picture here, huh? Okay. I'm expecting a picture. Apparently the picture is missing for some reason. Okay. So let's see if I can find that picture that was there in this location in my computer. Should be easy to find, I hope. Maybe not. Yes, found it. Ah, nice. There it is. So that's the picture that used to be right here in this location. Apparently something is broken, and so the picture doesn't show. But let's go look at the picture. And the picture is kind of useful to understand. So here is the picture. Now, what are we talking about? We're talking about creating a bucket in Seattle, or maybe in East Coast, in Virginia. It doesn't matter. At some location in the planet, on somewhere in, so you have a bucket. And what I want to do is draw this. Okay, so I have this bucket here in some location on the planet, but my customers are here and here and here and wherever they are. So it is kind of slow for them to access this bucket in my location. So how do I make sure that the customer here is happy? The customer here is happy. The customer here in South America is happy, and here in Africa is happy, and here in Sweden is also happy. So I want to make sure that these guys or people who are my customers, they're visiting my site that is in a bucket sitting somewhere here in Oregon or maybe in Virginia. That is a very long distance for a traffic to go and come back. And so what can I do to expedite the performance of these things that I have in one bucket somewhere and make it globally available with ease, without much work, because I'm lazy by definition. And so I am so lazy that I work hard so I can be lazy. And that's how lazy I am. So I do these things by hand, and then I do it again to learn it really, really well. And then I write code so that it becomes automatic. So I don't have to work anymore. So that's the whole goal of being lazy. And that is, I think you will see as a theme across the board in the boot camp, is how to be lazy. That's my goal in life. And so for that, I work hard, really hard, to make myself, or give myself the ability to be lazy. And so what I'm really doing is finding out a way where I can make my customers happy without doing a lot of work. And that is where this concept comes into play. And the concept is called Content Delivery Network, CDN. I think I will switch my pen and maybe open a web browser to talk about it a little better. So web browser, CDN, and here it is, the Wikipedia entry. Where's Wikipedia? There. Read about it as to what is CDN later on, not right now. Right now, you listen to what I'm saying about CDN. So what is CDN? You should read this, by the way, on Wikipedia, Content Delivery Network. So closing it. What I am going to describe to you is what is CDN. So what does CDN really do? So you have some bucket sitting here, and you have some stuff in there, and that bucket is here. And you have your customers here in another continent. And they will open up a web browser, and they will say HTTP, blah, 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 whatever domain that you have, subdomain, and it will do a CNAME record and find out that the actual location happens to be the site representation of this bucket managed by Amazon in this location. So the traffic will go, and then the Amazon will then send the content out, and the content shows up here, and it takes a lot of time. And it is slow. So imagine if there is a magical, by the way, there is no magic. Imagine that there is a magical solution available that makes a copy of this thing and puts it right there, close to the user, customer. And so the customer has to just go locally and access this item, and the item becomes visible to them right there. But it's a much more efficient model than having these customers from all over the world come here. That is very painful for them. So you want to maybe make this content, boom, available there. You have this customer who's sitting in this location, and they would rather just visit here instead of going all the way there. And so why not you make this content available right here? Automatically shows up here, so that when this customer wants to access the content, they will just go locally in their area, in their region, in their country, or whatever they have, or maybe the neighboring country, and then get this content available to them in a web browser. They are happy. But this magic is not magic. This is what, by the way, Content Delivery Network does. CDN will create point of presence. Points of presence. So this is a point of presence, this is a point of presence, and like that, there will be multiple geographically distributed points of presence that I have attempted to draw a picture like this. So wherever you see the edge, these are points of presence, edge. Points of presence created by the CloudFront network, which is the Amazon's service name for Content Delivery Network. That's what they call it, CloudFront. It's just the Amazon name for it. There are probably 100 companies or more that provide this service. All they do is make the content closer to the user. But there are some details to understand behind the CDN. The detail is like this. It doesn't magically appear. So if you have your origin location, where the original content sits, right there. Now you have this user in Malaysia, and that user wants to access your origin bucket in Seattle. So what will happen is that there is this Amazon location in Singapore that is there. I mean, Amazon has a location, a point of presence in Singapore. We know that, and everybody that uses Amazon knows that. But when this user, first time in the world, the user wants to access this. So what the user does is grudgingly goes to find out and gets the content, and the content shows up here in his browser or her browser. But while doing that, the first person to get the content suffers. Suffers meaning it is slow for them. However, the beauty behind a point of presence as a part of content delivery network is that a copy of this is stored right here. So the second person from Malaysia, person number 2, this person, when he or she visited this same site, they will not need to traverse to all the way that destination, but they can just access it from Singapore. And they will see the content right there. And it will be fast. Because the distance between Malaysia and Singapore is short. It's right there, pretty much here, in the region. The second person is happy. The first person was not so happy. But that's unfortunately the case. But that's okay. I mean, it is still better than everybody being unhappy. With the third person is also happy, and fourth is also happy, and the fifth person from Australia who comes on also happens to be happy because they will also grab from Singapore location, or maybe they have their own point of presence, which is not indicated in the picture. But they might, I think they have. So the content will become even locally available in Singapore, in Australia. And there is the content. So the second and third person from Australia, they will all be happy because the content is loading quick. So when the first one suffers, they feel that the performance is slow. This idea is called miss. CDN miss. Then the second person finds it quickly because he or she is able to get directly from Singapore location, is called a CDN hit. And so whenever there is a miss, CDN will automatically keep a copy locally in the region and then use that copy going forward for local hits, provided your DNS is configured to go like that. So if you have a DNS that has a CNAME that goes straight to this location, your CDN will not work. For the CDN to actually work, your DNS CNAME should not point directly to the bucket, but instead point to a CDN service provided by the CDN service provider, and CDN should be a cover to this. So origin, CDN as a wrapper. This is your origin. And your content is right there. And your users are here. And your DNS query will go to the CDN. And then CDN will know that they don't have it locally, so they will go and fetch from the origin, keep it locally, make it slow, make you unhappy for the first time, and then give you the item. So at least you grudgingly take it. Yeah, I got the item. It's not going to be in a bucket, but in a web browser, shows up. This guy is going to be happy because he or she is going to be local to the same region. So provided they are local, if they're in another location, like maybe in South America and you're talking about Malaysia, it's going to be a miss. And so this first user from the edge location in South America will need to get a miss. And when they get a miss, then CDN will take a copy locally, keep it in South America, right there. And then subsequent users from Brazil and Argentina and all the other places, they'll be happy because what you're really doing is a CDN wrapper around your bucket. You can put a CDN wrapper around anything. It doesn't have to be a bucket. Anything. Any machine, I should say. Not thing, machine. Now let's see an example of this discussion I just showed you. So we have this. I have 19, line number 19. I mentioned there's a CDN in play. So what I have done in the Cloud Seminar website, if you go and look at the BigQueries, you will find it exactly like I described. So in line number 22, give me a second, 22, what you see is when I say dig blog fungibleclouds.com, that example does not use a CDN, which means it is going straight to a DNS name provided by me and a site representation provided to me by Amazon. That's the CNAME that I put. There is no content delivery network in between this DNS name that I chose and the bucket which has a site representation listed like that, which is line number 22 on the right side. However, if you compare this with the other domain and try to find out, you will find that it has multiple IP addresses. These are the content delivery network CDN points of presence in our region. So what is going on is that the domain called the Cloud Seminar, line number 19, is actually pointing to the service addresses provided to me by the content delivery network service known as CloudFront. Here. Let's go to CloudFront. Cancel that. Come on, all the way to the top. There. And then here we have a service called Content Delivery Network, and that thing is hiding in network section somewhere. So networking here. It used to be here before in the storage section, but they have moved it to the content delivery as a separate section as a part of networking, which makes sense. It's classification. So the idea here is actually right there. The idea, come on, refresh the page. Hello, why are you not refreshing the page? Okay, refresh, no. Let me close my web browser. No, it doesn't want to close. Interesting. So I will kill it then. If it doesn't close, then it needs to die. Okay, come here and you Firefox should die. Force quit. Firefox is gone. So we'll start Firefox again. There is Firefox coming up with the networking and content delivery section, which has CloudFront. That's the service name or the marketing name for the service called Content Delivery Network. And what these guys do is they create a wrapper around whatever you want. In my example, a bucket called thecloudseminar.com. So that's exactly what you see here is this entry, which is, let me make it full screen. And you will find that the origin is a bucket called thecloudseminar.com/ S3 website representation in US West 2 Amazon. So there is a bucket there. This is the site representation of the bucket. This is the origin for this CDN. I have two, by the way. I have two CDNs in use. The one I'm looking at is the origin site representation of that bucket. And the canonical name I'm using is the Cloud Seminar. And that is deployed. So if you look at the detail behind it, it'll tell you that this particular content delivery network will use the front user-facing name as the Cloud Seminar, and the back-end name is going to be this. So let's go see what that thing is. So we'll copy that. The domain name that they have issued for the content delivery network itself is whatever that name is, this. Line number 20. Let's see if we can dig it. We'll dig that first. So, and what do you see? You see it is this, hold on. Okay. Let me open it. I'm going to make sure that I'm describing you correctly. So, opening that. Yes, yes, it is the same. So if you open that location here, this location is actually provided to me by Content Delivery Network, which is a representation of the Content Delivery Network's content, which is being picked up from the origin location, which is the actual bucket, which has a name that kind of sort of looks like this, but not exactly. So let me just construct that name for us so that you can see it, all these pieces together. And here's the name. The name is not Blog Fungible Clouds, but the cloudseminar.com. And it is not in US East 1, but it is actually in West 2. It is in Oregon, not in Virginia. So I modify that. And if I go look at this domain as opposed to 20 or as opposed to 21 or 19, I should renumber them. If I go to 21 or 22 or 23, you will find that I am reaching the same content. Let's go see first the end user perspective, line number 21, opening up a web browser and putting this on 50% of the screen. Right there and here. And so here we go, open the Cloud Seminar. And that opens up what you see here is what you find, is what you see. That content is what is sitting in the bucket. It shows up as the Cloud Seminar right there on top. If I now take line number 22 and open that in a new browser window, you will find it opens up the same content. Now, if I go take line number 23, open up a new browser window and paste that in, you will find the same content. So line number 21, 22, and 23 are basically the same content, but coming from various places. And I'll tell you exactly where they're coming from. So let's go look. The CloudFront distribution is actually distributing this D1WOC, whatever that line number 22 is. That's what CloudFront is giving me. So now let us see. Picture, origin, bucket, content. The name for this is 23, line number 23. Then there is a CloudFront layer around it, CDN layer. CDN has a name. The name is number 22. Line number 22, as you can see there on the right side. And then what I have done is users, people on the internet, when they want to visit this content, they don't know this line number 22. It is so difficult to remember. D1WOC, it is like yeah, complex. So I don't even want to read the whole thing, and nobody does. So what I have done is simplified it. What do? I call it the Cloud Seminar. .com. By the way, this site is not truly functional. I mean, it works, but it's not, nobody knows about it except you and me. But I'm working on it. Someday I'll find time and I'll build it and do something with it. But right now, that's not the focus. The focus is to understand what's going on. What am I doing? Why am I building it? Why this way versus that way? And there are various ways of doing things. But what we are really talking about right now is the idea of content delivery network and how they help me take content that I have and take it globally, like worldwide, without spending a whole lot of money. How much money do I spend? I think I already showed you, but I'll remind you that my Amazon bill is, how much is it? Billing. My bill for the month of September, we'll find out. For the October month, it is 1 cent. Let's go find for the September month. Okay, last month, how much did I spend? Last month, I spent 44 cents. That's my cost. And this month, I have spent 1 cent. And I'm forecasted that in October, I'll probably spend $1.33. Who knows? That hasn't happened, by the way. It hasn't happened yet because I actually don't use this much, except that I run content delivery networks, 2 of them. And I have that bunch of buckets. Like, this site is not super popular. Nobody knows about it. So nobody visits it. And there are not much visitors, not much content. So the content delivery network bill is also very small. And the content itself is small, so it's in a bucket and the buckets are cheap. But tomorrow, if I go to Oprah's show and there Oprah talks about the Cloud Seminar, what is going to happen is that the world will visit this site. And as a consequence, there'll be a huge bill showing up right there. Because lots of traffic means lots of bill. That means content delivery network is active, and so it's going to service your requests. And the more traffic you have, there is a charge for that. And so it's probably okay for large customers who are, large service providers who have lots of customers. And so that is okay to, maybe charge them a little bit of money so that they are getting good service. So the idea behind these type of services is that they're affordable, they're scalable. So you can actually go on Oprah and have her mention your site. And then you will get lots of customers and lots of money and all that. But that's not my goal. So I'm not going to Oprah. My goal is to help you understand that there is this service called Content Delivery Network, which is what we are dealing with. And that is what looks like this from a user's perspective. And line number 22 from a machine's content delivery network perspective, like that. And one step below is line number 23, which is the bucket perspective. So all of these 3 identical look, there's the same content, just coming from different sources. This is the origin, the actual place where I store stuff. This is the content delivery network's ugly looking name that I don't even want to read. And this is what I want people to go to, the easy to remember name. And here is where people actually, some of you and me and some of us go there because they want to find out what's there in the Cloud Seminar. And there's, by the way, nothing active. And there are things that are written down, but it's not ready. Let's put it that way. It's not ready. Not there ready yet. It will eventually become ready when I feel like. So having discussed this idea of content delivery network as a service to let customers use anything that they might have in a central location. Now, this doesn't have to be a bucket. It can be anything like a Kubernetes cluster, for example, or any service, like we just started this thing in EC2 and started a machine and run Nginx application and started a welcome to Nginx page. Even that can be an origin. And CloudFront can take custom origins. So for example, if you have this service, it is actually using, there is, by the way, another bucket example. I've been messing with this quite a bit. So there is this thing called docs.cloudgenie.us, which by the way is a different site, which is not ready yet. It is this site. And this site is there. And so it is not done. There's lots of things to do. And so I'm working on it. Eventually I'll finish it, maybe next year. But that is also a bucket, just like the other buckets you saw. So this is also a bucket in S3 called, what is it called? I think it is, I forgot the name. I think it's called CG site maybe. And it has a property to show static website hosting, which has this name. And so the same look and feel again pops up in a different name that looks like this. The name was, from a customer's perspective, docs. That was the name I want people to remember. This was the name from the bucket. And then in between, there is a CDN reference. So the CDN reference is, come on back, AWS, Content Delivery Network, right there. And go to the first CDN, this one, and examine. And here you will find this ugly name, whatever that name is. And so go open it up, and what do you see? You see the same thing again, like we saw before. And that is this ugly name. I don't care about these ugly names, but that is something that the CloudFront service, the Content Delivery Network service, is giving us. So we are using it. How are we actually using it? We are putting a CNAME record. Where do you do that? You say dig docs.cloudgenie.us and tell me what is your CNAME, and you find it. That this docs actually is a canonical name that points to that ugly name. And what is that ugly name? This ugly name is coming from here, from the CDN, which has used the origin for the bucket site representation. For the bucket representation is CG site, S3 website, US West 2, Amazon AWS.com, another complex sounding name, but opens up the same thing that you saw before. And it is line number 28, same thing. So the core idea to remember in CDN is that CloudFront is not the only solution in town. There are hundreds of such solutions. You can create a new distribution and get started, and you specify your origin, whatever that origin is. It could be buckets, or it doesn't have to be buckets. So when you don't have a bucket, then you need to create a custom origin. So you have to then create a origin custom headers and to create your custom sources here. And that basically translates to anything that you do in any cloud. You can use CloudFront as a wrapper. So anything you create anywhere, any cloud, even a machine in your garage. So if you have your garage and you have a computer sitting right there, it has a public IP, you can use that machine to run whatever you want and make that available to a worldwide audience. No kidding, it will work just fine, provided you cover it with a content delivery network. So that whenever a user hits, they hit the CDN, and the CDN in turn will go to your public IP address, grab the content down and make it locally available worldwide. To these users, same thing. To these users, the same thing. They don't hit your garage. So only thing that hits your garage is the CDN, which is okay. I mean, CDN is like taking it one time. If you change something here, then it'll get pulled, and it will be pulled by demand by the first unhappy visitor. That first visitor will suffer And when I say suffer, I mean it's like few milliseconds slow. It's not that slow. Yeah, but just realize that it is slow in the internet scheme of things. So if you make a change, that change has to be propagated. So that earlier that was a hit, but you made a change in the origin in your garage computer. You made a change. So now this hit becomes a miss. And this concept is called flushing, literally flushing the cache. Because content delivery networks are actually cache. They're caching content all over the world for you, for your origin, which can be a machine in your garage. It can be a bucket. It can be a Kubernetes cluster, like in my other example. So all these examples that you see in this website, no, not this. This website, they are all cached by content delivery network. And so this set of servers are not that big, but it is still functioning effortlessly worldwide. Lots of visitors from all over the world, because they don't actually hit the central origin directly. This origin happens to be in the Google Cloud, in a Kubernetes cluster. That is my origin, but I have a content delivery network around it. So people visit the CDN most of the time. Sometimes they get access because the content changes. And so, for example, a new user like you comes in and logs in. And so you log in as Emily, for example. And this content has to now show your name with a dashboard saying, hello, Emily, like that. And so this is where you will see that the content needs to be coming straight from the origin. The Emily name should show up. So that will be a slow response. You can probably not notice that it is slow. But you can measure it to be slightly slow the first time, and then subsequently it will be not slow because the name will be cached here. Unless you change something here, then it will be flushed, and you will see these things happen dynamically, automatically. That's the idea behind a content delivery network. There are many, many such content delivery networks, and here is another example. This guy is a Swiss company. And it's a good and cheap solution. And so you can see how many points of presence they have. So the reason I show it to you is because they actually show you a nice picture with global content delivery network points of presence available according to this company worldwide, as you can see from this picture. It's a Swiss company, and they have lots of POPs. And growing. So the number of points of presence are growing worldwide. They now even have in India, apparently, and Singapore, and Jakarta, Indonesia, and like that. And so multiple places. Most of it, if you see carefully, it is in the US, Canada, and Europe. That's where most of the modern, I should developed countries are. And so that's where you see lots of POPs, and other countries have very little POPs. But that's what they have. So this is just one example. Let's see other examples. So the best way to find out other examples of content delivery network is, of course, go to Wikipedia. And here is a list. Probably they will have a list. Where is the list? Here? Yeah. Here are some names of commercially available content delivery networks. All of these guys, notable content delivery service providers. You can see them, visit them. They all function the same way, same exact way, like we just discussed. So up until now, we have briefly discussed this idea of compute and some parts of storage. Some parts of this CloudFront thing, for example. And we kind of briefly touched upon Cloudflare as a DNS service provider. And we saw that as a live example on this domain when we were modifying DNS entries. And if you're dealing with other clouds, other DNS servers, they will look kind of sort of different. For example, GoDaddy DNS will be different looking, but it doesn't matter. They all store A records and CNAME records and MX records and NS records and this record and that record, and this website is full of those records. As you can see, I have so many of A records, so many of CNAME records, and it is for I have 142 records, by the way. So lots of these guys, lots of records for a variety of things that I'm doing, and they are just there because I do these things. That's the company that I run. So that's where we have DNS entries, and this idea is not just with Cloudflare. There are many such companies that give us what is this thing called DNS service, and even Amazon gives you one. Amazon gives you a DNS service. They call it Route 53 because DNS service runs on port 53. So the name Route 53 comes into play. It's marketing. DNS port is 53 right there. And that's why they have chosen the name Route 53 for their service itself. This functions exactly like Cloudflare. Looks different, functions exactly like that. It is not free. They charge you about 30 cents, 40 cents. Let's see the pricing. 30 cents per month for a domain. So it's not free, but it's a per month price. So 30 cents per month is like 1 cent per day. It's cheap. Maybe it's 30, maybe it's 40. But look up your price yourself. Cloud.google.com also has a DNS service. We go to the console and find out what do they call their DNS server. So they have a name for it. What's it called? It's called DNS. So this is also similar to Route 53 or Cloudflare, and it is also not free. So you create a zone, it's going to cost you money, and I think it is also like 30 to 40 cents per month. So Google DNS, Google Cloud DNS price. It's probably 40 cents per million queries per month. That's the price. So up to for the first billion queries, 40 cents per million queries per month, and very likely you're not going to make a million queries in 1 month, in the very first month. So it's going to be 40 cents. That's the pricing. So I think the same price will be for other DNS services like Google, for example. But this guy is free, Cloudflare. This one is actually free for DNS. So, but it is good free. I mean, don't take this free as bad free. It is actually good. I have tested it. It works out okay. I've been using it for 4 or 5 years now. It is nice and stable. No issues. And it hasn't yet caused worldwide trouble for other customers. Not even for me, not for others. So it's actually something that I would say, yeah, if you're seriously going to keep your domain, ditch your GoDaddy and come here. It's free and it's good free. And when I subsequently say the word free in subsequent sessions, I will not be meaning this when I say free, by the way. So subsequent to our discussions right now, free does not mean this. Free would mean freedom. That will be my definition of the word free going forward. Not this. In other words, libre. That's what I mean by free when I say free software. Free software is not $0. That's not what I usually mean when I say the word free. I mean these things. And that is what we will be using quite a bit as we go along. DNS itself is used, it uses a software called Bind, which is a free software. And you can see that you can run your own DNS server by running Bind. And here is your Bind software, open source, free software. And that is, let's see what the description of Bind is. Bind is by far the most widely used DNS software on the internet. I mean, everybody except Microsoft, they would use Bind. Your router in your home has a DNS server and it is using Bind. I can guarantee that. That's the most popular open source, the most popular DNS server. It happens to be open source. Microsoft has its own DNS solution, so they run it in Windows Server, but that's an aberration. 99% is this DNS server. That is what you see implemented in Cloudflare and in Google Cloud DNS and in this Route 53. So they're all running Bind under the hood. They don't talk about Bind, but it is Bind. So that was the idea behind DNS as a record where you keep track of what the names and IP addresses mapping, names and friendly name mapping, names of name server, names of mail exchanger, names of service record, names of this and names of that. And the whole thing is full. There is a write-up in our Cloud Genius website somewhere about DNS that you should read. Somewhere here in the Cloud Technologies section, you should find a reference to DNS. So you should actually, by the way, if you have access to all these things, you should review these things yourself on your own, by yourself. So here are some DNS concepts, A record, MX record, and SPF record, and other things that you should read because I may not be covering it. So I expect that you read whenever you find time. DNS section. By the way, read the whole thing. Go ahead. Finish it off before I cover it. I may not cover it because there is so much content that I may not actually cover each and everything here. So this is where I want you to be aware of the fact that you should read it ahead. By the way, there's a discussion on CDN apparently. So you should read that. So it's just something to read, not much. You read that. I already told you today about what CDN is and how to use it. And you first finish the homework that I just assigned to you, which is create a bucket, put in some content in there, give it a name that it looks like a DNS name, like www.corecast.com. That should be the name of the bucket. Convert that bucket into a site by marking a flag in the console. And then you get your site representation of the bucket, and then you create a CNAME for your DNS. For your www, make it a CNAME pointing to this, and you're done. You can then open your website and it shows up. Fill it up with content and the content will show up. Now, after you're done with this homework, we can now introduce the CDN aspects if you like, but that's a subsequent exercise. You can absolutely do the CDN and it's not going to cost you a thing because CDN is also free for you for the first year. At least read your terms and conditions, but very likely it is free. I'm not sure though. So it's not going to cost you a lot of money, probably 1 cent, maybe 2, something like that. So don't worry about money. It's probably free to your first year usage of Amazon services, but check. So we'll do the CDN later as an exercise. Let's go do this exercise. This doesn't require a command line. By the way, you can do the entire exercise just in a web browser. Now, once your command line gets ready, at that time, which is, I am assuming, is going to be Wednesday. So what is today? Monday. And yeah, by Monday, you should have a computer running your secure shell. So at that time, we should be able to proceed with the exercises that I have in our data center in the cloud section. This is what I want to do the next time, which means you should be ready with a virtual machine with a command line interface terminal up and running. That is a necessary thing. Without that, you will not be able to function. You can see me do it, but that's not the point. The point is for you to also be able to do it yourself, not necessarily exactly when I'm doing it, but anytime subsequent to when I do it. I think that is an important thing to have. So it requires that you have access to a command line, which will be in the virtual machine that will run on your laptop desktop on a non-company issued machine so that it doesn't violate policy. So up until now, we have discussed the idea behind, where is that? Here. We discussed briefly about compute, but not too much in terms of what exactly a VM does and how does it operate and how do you carve out a virtual machine out of a big computer. So for example, if you say data center and look at the images, you will see that these racks and racks of machines that you have, they are big, gigantic computers, each and every one of these racks. But then how do you create a small machine out of that? That is something that comes in as a part of virtualization. Virtualization is this software that some of you have used, some of you haven't. And this is just a local user-focused virtualization software that you and I are going to use. But in the data center, they don't use VirtualBox. So what do they use? They use other virtualization software. For example, to create a VM, there is an open source product called Zen. That's what Amazon uses, this software, Zen virtualization engine. That's the foundation behind Amazon's EC2. So when you launch an instance, you are actually invoking the Zen hypervisor that will generate a new virtual machine in a large machines somewhere here. In the data center, you will pick a portion, and then out of that portion, you create a small virtual machine, depending on whatever you ask, using the Zen software here. There is another one called KVM virtualization. That is another extremely popular open source product, part of the Linux toolkit. This is kernel-based virtual machine. KVM is also open source, and almost every cloud provider that is not Amazon, they use this KVM VM, KVM hypervisor. Almost everybody uses this. Amazon uses this. Both are good. Nothing wrong with any one of them. Just two different solutions available, both open source. And this is Zen, this is KVM. And what they do is create machines like these. So you pick an OS, and then you pick the size like that, and then you configure and do whatever you want. But the underlying thing to remember and understand is that it actually partitions your big machine. For example, in my case in point, I have this computer that you're looking at, and in there you have, where is that? Not this. Here. Yeah. Yes. So that is my machine. It is a 4.2 gigahertz Intel Core 7, 64 GB memory, some storage, 2 terabyte of storage, like that. Right? So if I want to carve out this big machine into small pieces, what do I need to do? I need to use a hypervisor, a hypervisor. What is a hypervisor? It is the opposite of a supervisor. Hypervisor. A supervisor supervises from the top. A hypervisor supervises from the bottom. That's the idea behind hypervisor. So what a hypervisor actually does is it allows you to partition a big computer into small pieces. As long as the smallest piece is still kind of sort of useful and usable, you can keep partitioning it into smaller chunks and use that chunk. How do you actually do these partitions, and who is responsible for them? And that's the idea behind a hypervisor. So KVM is a hypervisor. Zen is a hypervisor. VMware is a commercial hypervisor. Hyper-V from Microsoft is a commercial hypervisor. These are open source. They're good. I don't comment on these things because they're not open source. They're not free. And when I say free, I mean freedom, not $0. Some of these are actually $0, like one of these guys. Maybe, I don't know who. I don't care. I don't care about these things. I care about open source. And so that's what we'll be talking about. And so these hypervisors, and by the way, VirtualBox is also one such hypervisor that is used on a individual user's desktop. So here we have VirtualBox. And what we can do is take this big gigantic computer here and create a part of that. This will be a portion running Linux. Which Linux? So you classify that. I'm going to run Debian Linux, 64-bit. And then I'll go to export mode. And then here I'll say the name is portion running Debian Linux. And here I have total of how much memory? 64 GB installed. So out of that 64 GB memory, I can allocate a large amount of memory to the portion here. I can give it like 48 GB memory to the virtual machine, or even more if I like, all the way up to this point, 55601. I can totally give that memory to the virtual machine and live comfortably, because that's the threshold. You see the color changes to red after that. If I go here, what happens? If I give 58 GB memory to this portion, what happens if I do that? Do you know? What does the red color mean? It means that my actual machine will be starving for memory. This Mac OS will starve, and I don't want it to starve. So I need to move this pointer to this direction in the green area, because this is the bare minimum memory needed by this machine to run correctly. And if you look at the activity monitor and find out how much memory is being consumed, you will see that it is currently consuming about maybe 16 GB. So the rest out of 64, 48 maybe should be given. So something like this is probably reasonable. Rest should be left for the Macintosh to function properly. Because if I take a lot of it, then I'm starving my Macintosh. And then overall the machine performance, including the performance of the portion, will go down. I don't want that to happen. So it's reasonable to keep it low. That's the memory allocation. Now, if you further go ahead and look at other portions, let's see what else we need to have in this example. So if I go to global tools, let's see is there any other choice here? 64-bit, Linux, Debian. And I say create a virtual hard disk now, and I say, okay, create. If I click the create button, then it is asking me this question. How much disk capacity do you want for this portion? And I have how much? A total of 2 terabytes in the disk, in the storage on the machine itself, in this Macintosh, right? Here, 2 terabytes. Now in this machine called portion, I have this choice. Can I give it 9 GB? Yes. How about 4 terabytes? One terabyte. 4 terabytes, is that possible? No. What about 2 terabytes? Is that possible? I have total of 2 terabytes. about 1.42 terabytes is available, can I create a machine called Portion and give it a 2 terabyte disk? What do you think?
I'll say yes.
Okay, I think the right answer is yes. But can you tell me why?
Why you can do 2 terabytes?
Yeah, why should I be successful in creating a 1.89 terabyte disk when I actually have only 1.42 terabytes available? Why should I succeed? Only available storage is 1.42 terabytes, and I want to give this computer, the Portion computer, a size of 1.8. I don't have that much available. The right answer is yes, I can create. But the question is, why would it succeed? What do you think? Look at my mouse. Here's the answer.
No, dynamically allocated.
Yeah, so I can create it and it will get created. And I can even start it up and all that good stuff. But it is cheating. It is not actually, the whole space is not actually allocated. If you right click on it and say, show me in Finder, you will find that the actual disk is this file. And if you look at its properties, you will find that the properties of this disk image is actually 9.4 megabytes. Right there. 9.4 is totally doable with megabytes. So the actual disk allocated is 9.4 MB. The virtual allocation is dynamically allocated, and that is in the disk storage capacity is 1.89 terabytes. The actual size is 9 megabytes, and it is dynamically allocated. It means that if I fill it up with data, it will grow this number, actual size number. But when I start to reach this limit of 1.42 available, then the whole thing collapses at that time. Not right now. Not right now to work. I can put 1.4 terabytes of data in this disk, and it will be just fine. The moment I start to cross this limit of threshold of 1.42 terabyte available, at that time, this machine will start to cause trouble because not actual room not available. So the real machine has to have the real room available on that computer with a solid state disk, providing a place to store actual data. The actual size is small. That's the idea. Similarly, this machine that we are dealing with, this one, the one we are creating called Portion, it has a system memory of about 33.9 whatever MB, which is like 33 gigabytes of RAM allocated. That may not be necessary, so we can shrink it, but it's totally okay. You can give 16384 to give it a 16 GB memory, and that's probably a more reasonable size. So you can just say, okay, save it, setting, and what you're now looking at is the memory of this machine is 16 GB out of a total of 64. So taken 16 GB out of 64 is like a 1/4 of the machine. From a disk perspective, it is 1.8, as you saw here, 1.89. From a system perspective, from a processor perspective, I have 8 CPUs available. I'm only giving it 1. I can maybe give it 2 or 3 or 4. That is all okay. I don't need to and should not give all 8 CPUs because the actual underlying machine, Macintosh, needs some horsepower. And so in this machine, I can maybe give it 4 virtual CPUs, but not 5. If I say 5, it says invalid setting detected. and that is going to cause trouble. So 4 is okay, 3 is okay, like that. That's the idea behind processor allocation. You can also allocate physical address extensions and no execute bit if you like. These are special instructions available at the CPU level, and you're exporting that to the virtual machine. On the motherboard, you can allocate a floppy drive if you have one, or an optical disk if you want one or have one. You can even configure networks if you like. Or this is the boot order, by the way. The order: boot from network, boot from hard disk, boot from floppy, like that. You can attach the USB tablet, which is what I'm using right now in my hand, a pen and a tablet, and the whole screen itself is tablet. You can have that exposed to the portion machine. Similarly, the display is being shared with the display that I have and the display that it will show. You can also have a VNC display remotely enabled so that remote machines can connect to this and show the display on their computer. You can also make a video recording through video capture. If you capture the video, anything you do in the VM will be recorded in a video file, and that you can use to see if you like to review what happened in the machine. Similarly, the other ideas behind network are kind of interesting. What you're now looking at is a router. Yes, there is a router inside here. If you haven't seen that before, it will look like this. You have Comcast in my home, which comes in through a modem. To the modem, I then connect a router. And this is where I get a public IP. Everything inside the home are private IPs. Then on one of these machines is the Macintosh, the one you're looking at, this one. Now this machine runs VirtualBox, which is this one. It has one network adapter enabled. The other ones are not enabled. There are 4 of them, 2, 3, and 4, not enabled by default. I can enable them if I like, but not interested right now. What I am interested in is in the network section on the first adapter, which is enabled. What does that translate to? It translates to the fact that I have a private IP allocated to me by this router in my home, which is actually really a router. And then inside here is another router, which creates a subnet internal private IP allocated to the portion machine here, this machine, which is how I'm connected it to. So I have a router here, which is a software router running inside VirtualBox. And this is a real router. This is a real cable modem, real, connected to Comcast. So what you're getting is a network address translation happening here between public and private. And here another network address translation happening here between private and private. The address here is 10.0.1.128, if I remember from the last time. And so we'll go check. What is the network address? Where are you? Oh, where is Wi-Fi? There we go. And so here is the address. The Ethernet address is 10.0.1.128. And that's the address. That's also private, by the way, issued by the real router. Now here is the IP address, which is issued by this router. It is a software router, and it is assigned to this machine called portion. It's also assigned to the other machines inside. So if you go here and forget the portion for now, but instead look at the CloudGenius workstation and look at its settings, you will find that the network section has an adapter enabled and attached to NAT. This NAT is this NAT. And other adapters are not connected. Now, if you take that VM and start it up, you will find that this VM gets a private IP address allocated by this router. And that IP address here will be not this subnet, but will be a separate subnet generated by this router and dedicated to this machine, not the portion, but the Cloud Genius workstation. That's what you're looking at, is starting up. And when it starts up, you should be able to see the IP address that the router has assigned to this machine. And the address is 10.02.15, by the way. And here's the address, 10.02.15. And that is the address that this machine gets on the Ethernet adapter right there, 10.02.15. If you look at the machine's characteristics, you will find that this machine has, where is that? With the settings, detail, no. Network settings, where are they? Yeah, I don't know how to find these visually. I just go to the command line. It's easier for me because these UIs are, I struggle with UI. I cannot locate them very quickly. So on the command line, you can find it. It's right there. You can see that I have a Docker adapter and an ETH0 and a local adapter. In the ETH0 is the Ethernet adapter, which is 10.02.15. And that is what you see in this machine, the Cloud Genius workstation. Now, if you carefully look at the IP addressing scheme, you will find that this scheme assigned by this router is a 10.01.box/24, the CIDR notation. And this router assigns a private IP address in 10.02.box/24. It's a different subnet. Different. In between these two is a network address translation happening by the soft router inside VirtualBox, right there. Setting, network, NAT, right there. Of course, you can reconfigure this machine and connect it directly. So you can take this network card and say, you know what, NAT, I don't want to go like this. Yeah, remove this router. I don't want it. I want this virtual machine to be directly connected to this router. So erase that address and just erase this and give me straight inside an IP address to the VBox, Cloud Genius workstation, and assign me an address from the actual router. That's what I want. And how do I enable that? I will go to my LAN scan and scan all the addresses that I have, and we will find that I have today 34 devices. There is a chat request here apparently. So let me go see the chat. What's the chat? Let's see, read the chat. I had to drop. Oh, it's beyond 7 o'clock. See, thank you. You should remind me to stop. I keep talking. Okay, so let me finish this. And I understand that. Okay, so what I will do is quickly close this discussion where I am making sure that this box get an IP address in this CIDR notation in the actual router should assign from here. And I can enable that by connecting this directly in a bridge adapter. And when I do that, I need to save and then restart this machine. And when I do that, I should get a machine address straight from the actual router. So if I shut down this and say restart, this machine restarts and connects it straight to the actual router out there. And then we'll get an IP address in this CIDR. And it will be on LAN scan. It will become visible on that software here in the list. It will pop up. Right now there are 36 machines, and so new one is popping up soon. We'll find out what its IP address is, and you will see it here. And that is, machine starts up, it gets an IP address from the actual router because we have bridged it. And that bridging is what you see here in the settings in the network section for the adapter. Oh, still not bridged. Did I not save it or what? I think I forgot to save, apparently. Okay, and maybe not. I'll just reload settings. Maybe I saved it. I don't know. I'll find out. I'll cancel it out, reload settings, cancel. Go check the settings again. Go to the network. It is NAT. Apparently, I did not save. So we'll go bridge, and then I have to say OK and show the machine. And here we need to reboot the machine. So, or maybe reboot the service. So sudo service networking restart, and password is Cloud Genius. So service should have a new IP address, I hope. If not, I will reboot. And apparently I need to reboot. So sudo reboot, not remit, but reboot. Sudo reboot. So it's rebooting, and I think I should get the correct IP address this time because I forgot to save in the network section. Now it is bridged. Nice. Now the new machine as it boots should get a proper IP address from the real router. And that's how you can rewire virtual machines, as you see in this example. Rewiring meaning reconnect the cables according to what you desire. And that is what you see coming up as soon as the machine boots up. And we now have it in LAN scan. Right there, this Cloud Genius workstation popped up. It has an address of 10.0.156, and now I have 38 machines in my home. So back here in the virtual machine, in the IP address is right there, 10.0.1.156, which is right in that subnet, just like this guy. 10.0.1.156 is a part of this CIDR issued by this router, the real router, and this is a virtual machine, the Cloud Genius workstation. So that was a network concept, by the way, we just saw for live, for real. And we will understand this now, take the same idea to the cloud the next time. And with that, I will stop recording. And next time, if I go beyond, like I just did, stop me. Stop, ask me to shut up. And where is that recording button? So I'm stopping the sharing. I'm still here, not going away, making sure that I answer your questions if you have any, and I am stopping the recording right now.